Okay, today we're talking about factoring, some strategies for factoring some higher degree polynomials. So the first method that we want to talk about is factoring by grouping. So typically you're going to use this when you have a 4-term polynomial. So I think most of you should remember this from last year, so let's just go right to an example. So an example is something like x to the third plus 5x squared plus 4x plus 20. So I'm noticing that it's a 4-term polynomial, so I'm going to try the grouping method. The grouping method is pull the GCF out of the first two and then out of the last two. So the GCF here is x squared, which leaves me with x plus 5. The GCF here is a positive 4, which leaves me again with x plus 5. Now the whole goal is that these last two, these parentheses now are the same. So basically what you're going to do is factor out an x plus 5 from each of the terms. When you factor out an x plus 5 from this term, that leaves you with an x squared. When you factor out an x plus 5 from this term, that leaves you with plus 4. The next method we're going to talk about is a sum and difference of cubes. So if you have something cubed plus something else being cubed, this is an example of a sum of a cube. When I factor this, I'll kind of show you a trick in the end. I know this factors to like a little parenthesis and a big parenthesis. What goes in here is just whatever the first thing is being cubed and whatever the second thing is being cubed. I'm not going to fill in a sign there yet. I'll wait till later for that. Here, it's this first thing squared. The middle term is what you get when you multiply those two things that are being cubed. And then the last term in the second parenthesis is a squared. All right? So from here, after I know, I automatically go x, a, x squared, ax, a squared. Then I'm going to fill in the signs using SOAP. SOAP stands for same, opposite, always, positive. So if I'm trying to factor a sum of cubes, the signs are going to be the same as this one, then the opposite of the one that you started with, and then it's always positive. So the only thing that changes is if I started out with a negative, my signs go the same, the opposite of that, and then always positive. You may have used mop and pop last year. It's really telling you kind of the same thing about the signs. So let's go ahead and take a look at an example. Let's see, x to the third plus 64. Automatically, when I see that x to the third, I'm going to try to force and see if I could rewrite 64 as something to the third power. I know that that's 4 to the third power. So my little parentheses and the big ones, x, 4, x squared, 4x, and 4 squared, which is 16. Filling out the signs, same, opposite, always positive. And that's as far as you can go. This quadratic is not going to be further factorable. The next factoring method that we're going to talk about is called quadratic form. So you're going to kind of factor it like a regular quadratic. Which means like the double sets of parentheses type of thing. But really, this is just going to be a higher degree. So an example of this is starting out as x to the fourth plus 7x squared plus 10. Hopefully you can sort of see that it's like a quadratic trinomial that you would just factor this way. So you'll just write down your double parentheses. What's different though is what things have to go here to multiply to x to the fourth. Instead of just a regular x and x, it's going to be an x squared and an x squared. What goes here, you're still thinking about the numbers that multiply to 10 and add to 7, just like when you were factoring a quadratic. So in this case, it's a positive 5 and a positive 2. And that's it. And then one last example we're going to look at, and it's really just ends up being like something from above. You just want to first check for a GCF. And then the result is probably going to look like something from above. So for example, if we have something like x to the 7th plus 2x to the 5th minus 25x to the 3rd minus 50x, hopefully you can see that there's a GCF of an x that I would factor out first. And then I'm kind of seeing it's a 4-term polynomial. I might try grouping after that. So really, you should just first check for a GCF, and then it becomes one of the first things that happened up here.